Can everybody hear me back there? Yeah. I just don't want to be like up here. So, okay, everybody ready? I'm ready to go. So this talk is on how to stop the hack. For those who don't know me, my name is Jason Samide. I'm with Emerging Technologies Group. We're basically a security-focused consulting company. We're based out of Cleveland. We have a couple offices in Virginia area, one in San Francisco, Montreal, and one in London. Some of our customers that we've worked with in the past, I couldn't put them all up here, obviously, but this is a good mix of both government and some private companies that we've worked with. Anybody know the answer to this question? I never understand it. I thought that's, if I'm here, somebody might be able to answer that for me, but it's always somebody in a ski mask. It always kind of blows my mind. Right, but they're always like, in a room, and it just blows my mind anyway. But what's that? Yeah. So in some data center, they're always cold, and they have to keep it down and whatnot. So I always find that very amusing. So basically, how I'm going to define a hack is basically it's an unauthorized access or gaining access or some sort of something with a system. So you're either taking intellectual property, credit cards, any kind of data, right? PII, all that good stuff. So typically, it's changed on why people do these hacks. It used to be, hey, I got your router in the 80s or 90s, haha, I can reboot it and get some logs and whatnot. That's really changed dramatically. Now it's more for protesting or hacktivism. And obviously, we've seen in the last even year with Target, JP Morgan, Home Depot, whatever. It's a lot more for that secondary market, or that black market for credit cards and HIPAA data and all that good stuff. So that landscape just in itself on why people hack or attack these systems has changed dramatically. So when you look at the malware life cycle or how these are created, there's a lot of different players, and sometimes it's the same player, but you have malware makers, you have malware sellers, you have malware purchasers, and this huge ecosystem, if you will, of this underground, literally a business where anybody can go if you're not anonymous, but without being known, can go there and say, I want to buy malware to do this, or I want to look for that, where you have actual places you can go to purchase that. So one of the biggest things that obviously in the security place today is, where is all this malware coming from? Is it state-sponsored governments, organized crime, things of that sort? So they always seem to be staying one step ahead of us, and I think it's because of this huge network of things. And they even have certain measures built in for resiliency. So if one bad website goes down, no problem, because I have this DR, this other resilient website over here that does the same thing, whether it's through DNS or domain URL hosting, whatever the case may be. So this specific talk about stopping the hack, there's 4 pieces basically to what I could consider to be a hack. So you have your exploit. So basically, they'll find a vulnerability, they'll create some sort of exploit to attack you, they'll find some way to have you unpack that piece of malware. It will look for what it's looking for, so that lateral movement. So whether it's looking for intellectual property or whatever, it's looking across your network to find that. And then the last one, it'll pack it up and exfiltrate that data, and sometimes, or most likely, without you knowing it. So your typical exploits are web, email, and human, right? So what I'm going to do is I'm going to talk about each one give you an examples of some of the exploits and how you can counter those exploits. So, especially with the web, you get in typically through malware, through client-server type technology, cross-site scripting, everybody's heard of clickjacking, things of that sort. A lot of times when you go to legitimate websites like CNN or MSNBC, you'll get a lot of these drive-bys that they're hosting these bad advertisements. So how do we detect that? Excuse me. Web application firewalls, they'll get you so far. There are also, malware out there that can circumvent web application firewalls. So that's always maybe a block and tackling type technique. You can always do those web scanners that can constantly look for new vulnerabilities, whether it's daily or hourly, things of that sort, and patch those things. But again, that's still not 100%. There are purpose-built malware detection systems that either look at your ingress traffic or your egress traffic through your website, and some of those can be pretty effective. And one common theme that you'll see here throughout these slides is the SIM. Not so much the type of SIM that you have, but how that's tuned, or what type of rules that you have in place to detect more so the lateral movement versus the data exfiltration, and so on and so forth. So SIM is probably in my opinion, one of the key tools. Email. The worst part about email is every company needs it, and every company lets it go, right? So you're not going to ever block port 25 to get incoming email or send email out. But you can have, there are some other malware protection devices out there that are specific to email, where anything HTML with an attachment needs to go and get scanned or looked at by this particular device. But then, even if it's legitimate mail, again, the attachments that are involved. So PDFs, Word documents, things like that. These are very common type files that we, as organizations, we're dependent on that. So it's very difficult to look at all those attachments. And I think that's how RSA was attacked a couple of years ago, through either a spreadsheet or PDF that somebody openly opened up and said, hey, this is executive compensation or something like that, and unbeknownst to them, started unpacking some piece of malware. So email, again, you have these spam filters, but even that spam filter is just for spam. So if somebody's just sending you junk mail, that's not so much maybe malware. So it's okay, it's good. It's that blocking, tackling type technique. You can't only allow plain text to prevent images. That would certainly reduce the amount of malware. But again, is that realistic? I mean, the way emails are sent today, and so often with mobile devices and iPads, it's very hard to say we can only allow text email. So again, with the email protection systems, those are very purpose-built for anything HTML with an attachment. They have to be scanned by this device before that user can read that email. And typically also regular awareness programs within your organization. Phishing has become extremely popular simply because every organization knows they allow email through. So having that awareness where individuals can look and say, before I click this, let me look at this. Who is it coming from? Does it look like our email system? Does it look like our signatures that we have or that we use within our organization? And say, is this a legitimate email, or is this somebody phishing? And honestly, don't be afraid to ask, hey, boss, did you send this email about healthcare? Something like that. So that's all intertwined into some of those user awareness training programs. And again, human, that's another, probably the biggest one as well. Although USB drops probably have not become as popular nowadays, a lot of folks just disable the USBs on their machines. So a couple years ago, that was the thing to do, but now it's kind of like, if you don't have your USB disabled, then obviously that's a huge exploit. As far as the help desks are concerned, there's a lot of social engineering. Again, it's kind of coming around as being a very popular way of getting into an organization. I know in the last couple months we've had that couple situations where we'll go into an organization and ask for help desk and actually get passwords and gain access to systems that way. And if you come up with a decent enough story, I mean, anybody can pretty much get that stuff, right, Tyler? And again, direct user contact. I mean, there's so much information out there on different companies or different people out there, that open source intelligence that's out there. It's very easily, whether it's LinkedIn, social media websites. It's almost like a calling card. I mean, if you look at even LinkedIn, for example, people will tell you, I work at XYZ company, and I have experience using Juniper firewalls, Checkpoint firewalls, or Palo Alto, or whatever, and they, DLP and whatnot. So basically, you just provided me a little bit of a roadmap, or the roadmap, and how to exploit or get into your organization based on just those little facts, right? So if I know there's an exploit for Palo Alto, great. I know that XYZ company uses those. I can go ahead and try to do that. So then the unpacking. So typically, when that piece of malware does get unpacked, it doesn't, pop up and say, "I'm unpacking." So that exe typically runs in the background under a trusted application or trusted exe. So you look at the application whitelisting, which is great, and it can work for you. But if that piece of malware is using a trusted application like Word document or Word.exe, you'll never know, and that whitelisting solution has basically just been spent. So there's also a lot of other means of the DLL duplication where we as end users don't see this happening. It's all happening in the background, so it's very difficult to see that unpacking take place on a person's workstation. But again, as far as detection, you can do some file integrity monitoring, whether that be on a server and or an endpoint. Antivirus, that's only works so far, right? If it's nothing that the antivirus has seen, and it's garbage. I mean, I think it wasn't for PCI, I don't think that organizations would use it anymore, but still. And again, getting back to the SIM piece is again, if it's tuned correctly and done right, could potentially see that unpacking on somebody's workstation to say, this is happening on this server that shouldn't be happening. So again, SIM is going to be one of the common themes here in this discussion. And then you have the data exfiltration piece. So it's looking for something, right? That PHI, PCI type information, credit cards, things of that sort. So it'll basically package it up and at a very slow rate leave your organization. It never leaves in big chunks at a time. It's going to look like regular normal traffic. In a lot of cases, when malware isn't as smart as it should be, it does pack it up and sends 4 gigs of data out at 2 a.m. And your SIM is like, that's not right, something's going on, right? That's the way it should work. But if it's trickling out at, less than a meg every hour, or takes, a month to get that data out, that's typically what we see in the environment. So again, some detections for the data exfiltration. You can do some firewall reputation enforcement. Again, that SIM fingerprinting for the packet analysis. And the one thing that I've been working towards, and when I speak to customers, is for the last 30 or so years, everybody has their perimeter firewall and is always concerned about what's coming into the organization. But if you kind of have to have some sort of paradigm shift and do some egress filtering and try to understand, or at least care about what's leaving your organization, even if it's user traffic. I mean, do you want them to go here or there? So instead of worrying about what's coming in, I think we need to also start to worry about what's going out. And egress filtering is something that every organization should at least look at. But again, in here, the SIM is also very important to understand what type of data, if anything, or what type of traffic, again, if it's tuned correctly, in a normalized situation, could say this type of data should not be leaving at this time from this person, or why is this particular computer even communicating with something in Russia? We have no legitimate business over there. So again, as long as it is tuned correctly, the SIM should be able to pick that up. So as far as some of the data detection prevention, DLP can be pretty handy. Again, if that's tuned correctly, a lot of folks just say, DLP is boil the ocean and hope for the best. But a good DLP program could potentially affect some certain files that are leaving and so on and so forth. And also disallow some very common services and ports and so on for media sharing, online storage sites. I know those are becoming pretty popular. I know Dropbox has probably had its fair share of knocks and whatnot, but a lot of folks, a lot of companies are building their own Dropbox-like websites simply for that very reason. So basically, here's in a nutshell the cycle of how this works. So you have this particular site that goes down to this computer and goes and gets a file, and potentially, through man in the middle or whatever, redirects to another website. And then that particular website, client-server technology, drops it down, puts that dropper on that end user's workstation. And again, it does this unpacking and kind of goes into lateral movement and says, I want to look for this and that and what else I can get my hands on. And basically does a little command and control back to some server or some other place at some different location and says, okay, I'm here, I'm unpacked, I'm waiting for you to tell me what to do, what other commands to do. Then they communicate. Then there's another server potentially based on that ecosystem that I had that slide earlier. It says, okay, now that you're here, you've been dormant or whatever for X number of months or whatnot. Here's your new commands. I want you to go back down there and look for this type of data, whether it's PDFs or Word docs, PAI, whatever. And then here's where it basically says, okay, I found all this data. I'm going to start to pack it up, and then I'm going to send it out to a different server. So basically, this is the whole cycle, if you will, of how that malware piece works. And again, it's those 4 steps. So if you can basically stop any one of those 4 at any given point in time, you basically have severed that entire communication, and that data will obviously never leave. So I mean, obviously, there's a lot of theory and hypothesis in this, but it really boils down to a lot of people, process, and technology that could potentially prevent a lot of these types of hacks. Other countermeasures, I know browser-based virtualization is becoming pretty popular. So instead of actually going to Yahoo or CNN, whatever, you're actually doing it in a virtualized browser, if you will, through some other sort of technology. So basically, what that would do is it's proxying that session for you that says, based on where you want to go, it's going to download whatever it is into that virtual browser, and then understand whether or not there's malware before it even gets to you as an endpoint. And anybody have any questions? Yeah. Have I used? There's a lot of them that are out there, and it really depends on the type of data, whether it's structured or unstructured. I'm familiar with the Semantic product. It used to be called Vontu. The McAfee has a decent product out there, and the RSA one as well. I've not worked with any open source ones in the commercial environment. So, but again, it really depends on the type of data you're looking at. I mean, it's a lot of times customer or corporations may have some more unstructured data if they're like a manufacturing or things of that sort. So, kind of gravitates more to the enterprise solutions. Anybody else have any questions? No? Okay. Awesome. Thanks.